We're going to take a look at the history of vaccines and herd immunity in this lecture. Let's take a look at the history of vaccination. Variolation, this was the first way that people were protected against smallpox. What they did is they would take the pustule scab material from a person infected with a mild case of smallpox, and then they would administer it to the person two ways. So either they would blow the dried scab material up the person's nose, which sounds really gross, or they would make a mark on the skin and then rub in the scab material into the skin. So they would actually give the person smallpox. The hope was that you would get a mild case of the smallpox, you would survive, and then you'd be protected the rest of your life. Unfortunately, there were some people that did die and got a severe case of smallpox from the variolation. So Edward Jenner came along in 1796. He was an English physician, and he decided there had to be a better way of protecting people against smallpox than using variolation and actually giving the person the disease. So he came up with the first vaccine for smallpox. He noticed in his village that the milkmaids never seemed to get smallpox. So in talking to them, he figured out that they had all been infected with cowpox. Cowpox is a virus that is very similar to smallpox, but just causes very mild pustules on the hands of people that would get the cowpox. So he decided to take a sample of the cowpox scab material, and he grabbed his gardener's son and made a mark on the child's upper arm and rubbed the cowpox material in there. The boy developed cowpox, but then he recovered. And then a couple weeks later, Edward Jenner exposed the boy to actual smallpox. And luckily for the boy, Jenner's vaccine worked. And that's very unethical. We would never do that today, but that's what he did. So that was the first vaccine that was developed. So he was actually giving people cowpox, which would protect them against smallpox. And the word vaccine, vacca means cow, so that's where the name vaccine came from. And then remember talking about Louis Pasteur. Remember that he discovered attenuation. So attenuate just means to weaken. So he figured out that if he grew the bacteria or viruses in unfavorable conditions, the bacteria and viruses would not be able to cause a severe disease, and so he could develop vaccines from them. So he developed a number of vaccines. Herd immunity is really important, so make sure that you know this for the exam. Herd immunity occurs when a large percentage of the population is immune to a pathogen, and this prevents the spread of the pathogen through the population. Herd immunity can decrease, though, if new susceptible individuals are introduced into the population, so for example, the birth of new babies. And then we can also lose herd immunity if the pathogen changes. So we talk about, with the influenza virus, antigenic drift and antigenic shift. So star these are really important as well. Antigenic drift are smaller changes in the flu virus due to mutations. So this is what the flu virus does every year. It mutates. It looks a little bit different than last year, so you have to get a new flu vaccine every year. Antigenic shift, this is a major change in the virus. So this is due to two or more viruses recombining and forming a brand new strain. So we don't see antigenic shift very often. Like with the 1918 influenza pandemic, and then 2009 we had another influenza pandemic. Those are examples of antigenic shifts. So we had some really major changes. We had several viruses combined together, produce a new strain that no one has seen before, and so no one's going to be immune to it. Here's just an example of how herd immunity works. So the picture on top, we have no herd immunity. So we've got a sick person in red. They come into contact with this blue susceptible person, And then this susceptible person gets sick and they come into contact with another susceptible person. And so you can see how the disease would spread very rapidly through the population. And this is what's happening right now with the coronavirus, because we don't have a vaccine and most of us are not immune to it yet. We haven't had it. If we do have herd immunity, that means that we have these people in yellow here who are immune. Either they've already had the disease and recovered, or they are vaccinated for it. So if this sick person comes into contact with someone that's immune, the immune person will not get sick. And then when they go home to their family, maybe they have some kids that are susceptible to the disease, they will not pass that on to the other person. Here's another picture of how herd immunity works. So the top picture, there's no herd immunity. All the people in blue are susceptible, and we have two people that are sick that have come into the population, and that disease is going to spread very rapidly through the population. So that's what's happening with coronavirus right now. On the bottom, we have herd immunity. So we've got a large portion of the population that is immune. So these are the people in yellow. So they've either been vaccinated or they've already been sick with the disease and they've recovered. So if you do have some sick people in the population, it's very unlikely that the disease is going to spread very far to the susceptible blue people, because you've got all of these people that are immune that are in between the sick person and the susceptible person. So this will protect the people that are susceptible in the population. So you can see that only one other person in the population got sick. So here's just a nice little animation that shows how herd immunity works. So starting on the top left, no one is vaccinated, no one is immune, so pretty much everyone gets sick. And then you can see that the more people that get vaccinated against the disease, the less the disease is going to spread in the population. So you can see when you have 95% of the population immune and they've been vaccinated against the disease is not going to spread to very many people. Here's one way we can lose herd immunity is when the pathogen changes. So this happens with the flu virus. Antigenic drift is when we have mutations causing small changes in the virus, and that happens every year with the flu virus, and that's why we have to get a new flu vaccine every year. The antigenic shift is not going to occur very often. This is when you have two or more viruses that combine together to form a brand new strain. So this happened in 1918 with the Spanish flu pandemic, and also 2009 with the H1N1 flu pandemic. So this is just showing you antigenic shift. This is what happened in 2009. We had a pig that was infected at the same time with 3 different strains of the flu virus. So it had swine flu, avian flu, and human influenza. They were all in the same pig cell, and in the process of making new virus, the parts all got mixed up and we got this new strain of influenza. So that's what happened with the H1N1 influenza pandemic in 2009 and also in 1918. So that doesn't happen very often, so we don't see antigenic shift occurring very much.